Okay, we're going to go over volume of a cone. And this formula for volume of a cone states that 1/3 times pi times r squared times h is equal to the volume of a cone. I want to draw your attention. This is very, very similar to a couple formulas we learned before. Does anyone know what they were?
Yeah.
We're finding volumes of something else. What did we find a volume of? That's right. We were finding volumes of pyramids, right? So a volume of a pyramid was the area of the face times the height times 1/3. So let's draw a similarity here. This is the area of the face. Pi r squared is the area of the circle at the bottom. So this is the area of the face. We still have our height, and we're still multiplying by 1/3. So this is identical to a pyramid. The only difference is the face we're solving for is a circle rather than a square or a triangle. Okay? So as long as we knew the volume of pyramids, we can apply the same information to the volume of a cone and figure out what the formula would be. So we're going to go through two questions here. Our first question here, they want us to find the volume. Okay? So what is the volume of this cone? So we're going to write out our formula. Volume of a cone is equal to 1/3 pi r squared times h. First of all, do I have r?
No. You have the diameter.
I have the diameter, right? That's right. So we're going to divide this by 2. And when we take 10 divided by 2, like Travis said, we get 5 centimeters. Oh, sorry, meters. Thank you. Okay. Now, the other piece of information we need is our height. Do we have the height? No. How can I figure out the height of this object from the information we have? Pythagoras Theorem again. Good. So again, we have a right angle triangle. The hypotenuse is 8. One of the arms is 5. The other arm will be our h. So let's use Pythagoras' theorem here. C squared is equal to a squared plus b squared. What is our c?
8 meters.
That's right. So we have 8 squared. What would be 8? Or sorry, a?
5.
Sure. 5. And what would be our b?
Unknown.
Unknown. What are we going to call it?
H.
Right? We're looking for h. So the goal is to isolate for h. So let's figure out these numbers. What is 8 squared? 5 squared?
25.
And h squared? Good. What do we do next?
You subtract 5 onto the other side and make it negative.
Great. 64 minus 25 is equal to h squared. What does that become?
27. 29.
What is it?
39.
39? Great. And what is the height here? Are we done?
Oh, yeah, square root square.
That's right. We need to find the square root of this. So let's double check your math here. 64. Beautiful. Square root 6.2. We'll round it to. Yeah, to 6.2 meters. So we just discovered that the height of this triangle is 6.2 meters. I want to use logic. Does this make sense?
Yes.
Why?
Because it's smaller than the hypotenuse.
Very good. What about this 10 meters? Does that make sense with this triangle?
Yes.
Why? But is the 10 in reference to this? What part of the 10 is in reference to that?
Half of it.
Just half of it. Is 5 make sense?
Yes.
Good. Great logic. Okay, so we now have all the information we need for the volume of this cone here. Extend the page a little. It's going to be a long page. So our volume of our cone again is 1/3 times pi. What was our r in this case? And what was our height?
4.
4? Oh, I thought it was 2. Oh, you're right, it is. No, it's 2. Okay. So now this is simply putting values into a calculator and multiplying. So we have 1/3 times pi times 25 times 6.2. Okay? I put those dots there. They're essentially multiplication, or I could put brackets. I just want you to remember that we're multiplying all these values together. That's what this means. We'll do this in our calculator very quickly. We'll take we'll take pi times 25 times 6.2. Exactly. And we'll divide it by 3. 162.3. 162.3 meters cubed. Now, the first part we're done. I figured out the volume. Example 2, they've given us the volume and they've given us the radius. They want us to find the height. So we're going to take our formula and see if we have enough information again. Remember our formula from before? We'll plug our values in. What is the volume? 210. 210 is equal to 1/3 pi. What's the radius?
4.
And the height is unknown. The height is what we're trying to find. So the goal here will be to isolate for height. So there are a couple ways we could do this. The first way might be the easiest, is to get a value for all of these before we move anything over. Okay? So we have 210 is equal to, let's put this in a calculator. What is 4 squared, guys?
16.
Great. 16 times pi is equal to, okay, so that's the first two parts. And then when I multiply by 1/3, it's the same as dividing by 3. 16.75. Well, 76. 16.76. So I've just equated all of this, and I'll put it in red here. And the height is still unknown. In order to isolate for height, how do I move that 16.76?
You move it to the Pythagoras Theorem.
Because it's multiplied by h, we have to divide it on the other side. So 16.76. So this will now isolate for h. H will be equal to 210 divided by that number. So 210 divided by 16.76. 12.53. 12.53. And because we're in centimeters, and it's just a measurement of length, it's not squared or cubed. The height is equal to 12. I forgot already. 53. No, we had the rounding. Centimeters. So we're going to do 2 examples there.